Hi everybody, so this is the first in a series of video math lessons that we're going to be doing. So now for homework, sometimes you'll have problems in CP/M, sometimes you'll have Freckle, and sometimes you'll have these video math lessons. These are video mini lessons. They're designed to be short, and I'm going to keep them very quick for you because they're designed to be watched. As the video is unfolding, there'll be a moment where I'll say, hey, pause the video and work on this problem. Then you'll pause the video, continue to solve it, and then unpause it, and then we'll solve it the rest of the way together. That way, if you're stuck and you're not sure what to do next, you can watch the video to see it unfold. But when there's a moment in the solution to the problem, as I'm solving it with you, if you're still learning it and you want to make a guess, then you can pause this video anytime. And pause it, continue to solve it, and then unpause it and see if you are right. And I strongly encourage you to take that risk and to not just wait until you get to the end and copy down what I've written, because I really want you to try and challenge yourself to learn this content and to practice it and to be challenged by it, okay? So, but that being said, sometimes the video lessons are going to be a friendly concept or a review. For example, today's is a review mini lesson, which is great. We're reviewing the multiplication of decimals and how that works, because we're going to need that a little bit later on for a future idea that we're doing in class. So I want to make sure we've covered it here first. And so let's just jump in. All right. So the math problem that we're going to be solving today, there's actually going to be two problems we'll do, but the first problem is here. Before we start, set up your page. Date, today is the 20th of January. And I would write down underneath it that it is a video lesson, because it's to separate it from the class lesson that we did this morning. So I want to make sure that you have your notes reflect that this is the video lesson, okay? So our math problem that we're solving today is 3 25/100 times 12. We'll start off with a decimal times just a whole number. And so what's actually really important for us to do is to start by making an estimate, right? And so if it was just 3 times 12, if it wasn't the 25/100, if it was just 3 times 12, what would that be? 36, right? And so we know that our answer is going to be somewhere in the neighborhood of 36, because it's 3 and then a little bit more. This 25/100 is just added on. It's a decimal for this 3. Right? So we know that it's 3 times 12 is 36. So it's going to be more than 36. We know it's not going to be less than 36, right? But it's going to be in the neighborhood of 36. It's pretty close. All right. I wrote it horizontally because I want to make sure that we check in about how to rewrite these problems when you've got to write it vertically. And so even though 3 25/100 in terms of the value of that number is smaller than 12, I'm going to put it on top because it's the longer number, right? It has more digits in it. So I'm going to make it the one that's on top times 12. And then we just solve. Solve it like you normally would solve a multi-digit multiplication problem. I want you to pretend for a moment. I'm going to turn this dot invisible, this decimal point invisible for a moment. Let's see, well, I think this is the best color I have for it. So, okay, I want you to pretend that it's become invisible now, right? Don't you sometimes, when you want to make something look invisible, you write it blue? Well, okay, it still doesn't look invisible. But I'm going to pretend that decimal point is not there. And we're just going to multiply just like normal if it was 325 times 12. All right, so pause this video, multiply that on out, and then I'll rejoin you here in just a moment. Great, let's get going. All right, so we start in our ones place here, and we multiply times what would be the ones place if that decimal point were imaginarily not present, right? Ones place times ones place is 2 times 5 is 10. I'm going to put my 0 there, regroup my 1. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6. So now I've got my first row done. Now I have my number that's in the tens place here. And because it's in the tens place, my answer starts in the tens place. So I have my placeholder 0. I like to put a little smiley face in there to remind myself how happy it is that I remembered to put it there. So 1 times 5 is 5. 1 times 2 is 2. 1 times 3 is 3. And now I'm done. Now I have two different rows. I did my 2 times 325. I did my 1 times 325. Now I add them together. 0 plus 0 is 0. 5 plus 5 is 10. Regroup. 6 plus 1 is 7. 8, 9, and 3. So here's my total when I multiply it. If my decimal point were not there, it would be 325 times 12. I'd end up with 3,900. Now remember that the decimal point is there. So now I'm going to bring it back. Now it's here. And here is our step. We got to make sure that our decimal point is in its proper location in our answer. And you have become very familiar when you're adding decimals to just drop your decimal straight down. Well, it turns out that our decimal is going to go right where it would be if I dropped it straight down, but that's not why it's there. It's there when you multiply because we count how many digits are there to the right of that decimal point. How many digits are there to the right of the decimal point? Well, it turns out there's 2 digits to the right of the decimal point. My decimal point's right here. There's 1, 2 digits. Because there's 2 digits to the right of the decimal point, I move my decimal point from the end 1, 2 spots. And so that is where my decimal point goes. It's not because it drops straight down. That's adding or subtracting decimals is when it drops straight down. For multiplication of decimals, you have to count how many digits are to the right of the decimal point, and you move it that many spots over from the right. All right? And so let's go back in and check. Remember, we talked about just a moment ago, what would be a reasonable answer? And we said, well, 3 times 12 is 36, but it's going to be more than 36. And we ended up with 39 because we have 12 sets of 25 hundredths, right? And think about 25 hundredths as a quarter. And if you have 12 quarters, 12 coins that are quarters, right, that's $3. So it was 36, but now we have 39 because of those 12 25-cent quarters that we're looking at right here, right? So it's important when you multiply to make sure you make some sort of estimate, make a guess to see if something looks reasonable or not. And this answer is perfectly reasonable, all right? Here's our second problem we're going to do real quick. It's written vertically. I want you to write it. It's written horizontally. I want you to write it vertically. This is another opportunity for you to make sure you've lined up your digits the way you need to. All right, take a moment, rewrite it. So our estimate, right? 25 hundredths. Please remember that that's the same thing as 1/4. That's one of those benchmark decimal fraction percents that I want you to keep in mind of, right? So this is 1/4. What is 1/4 of this? $42.14. What's 1/4 of that? Well, if this was just a 40, what's 1/4 of 40? 10, right? So my answer is going to be somewhere in the neighborhood of 10. And it's going to be a little bit off of that, but that's because obviously we're not dealing with 40, but it's close to that. So that's going to be a good estimate for us to keep in mind. All right. So go ahead, solve it. Don't forget, we're going to turn our decimals invisible for a moment. Actually, I'll make it like this. I'll make it like a little hollow dot. Okay, here's our invisible decimals for a moment. And just multiply like normal, like you would. All right, so pause this video and go ahead and solve it.
Here we go. 5 times 4, because we're going, what is appearing to be our 1 slice times 1 slice, the furthest to the right digit. 5 times 4 is 20. Regroup my 2. 5 times 1 is 5, plus 2 is 7. 5 times 2 is 10. Regroup my 1. 5 times 4 is 20, plus 1 is 21. So I've done 5 times this whole thing.
That's this row. Our 2 is in the tens place. We want our answer to start in the tens place. So I have my placeholder here.
2 times 5, excuse me, 2 times 4 is 8. 2 times 1 is 2. And I want you to notice that it feels weird because I did 2 times 1, and I want my answer to go right underneath where I was multiplying, but my next available spot is right here. Having this placeholder 0 kind of pushes all my answers over a little bit, right? So 5 times 4 is, excuse me, 2 times 4 is 8. And even though my 2 times 4 looks like it should be here, it's here because everything gets shoved over, and that's by design, right? That's correct. 2 times 4 is 8, 2 times 1 is 2, 2 times 2 is 4. I'm gonna write that down. 2 times 4 is 8. All right.
Now I have this 0 here, and some people like the idea of me multiplying that out too, right? And you can if you want it, right? Might as well. 0 times 4, oh, gotta do my placeholder and a placeholder, right? Because my answer is right here in the hundreds place. The answer has to start here in the hundreds place, right? So I have 2 placeholders to move myself over.
0 times 4 is 0, 0 times 1 is 0, 0 times 2 is 0, 0 times 4 is 0. Right? So now what I do?
Add them up.
Zeros. 7 plus 8 is 50, plus 0 is 15. Regroup my 1. 2 plus this 1 is 3. 4 plus 1 plus 0 is 5. 8 plus 2 plus 0 is 10. And hit my 0 and regroup. And then there's a 1 here because 1 plus 0 is 1. So I've got this long number here now in my answer.
But we're not finished because we have to bring our decimals back, right? So I'm going to make them invisible. I'm going to re-visualize our decimal points. Please remember that how we determine the location of where the decimal point in the answer is not by dropping it straight down, even though it's really tempting to want to do that because these 2 decimals are lined up already up here. But how many digits are there to the right of the decimal points? Well, now I have 2 decimal points to look at. I've got 1, 2, 3, 4 digits that are on the right side of my decimals. I start here and go 1, 2, 3, 4 spots in. And that is where my decimal point goes. Right there. Right? Because there were 4 digits to the right of the decimals. I move it 4 spots over. And that is where it goes. All right. So my answer is 10 and there's a 0 here. I'm wanting to mess with here. 10 and 5,350 10,000ths is the answer. But don't forget, we're talking money here. And if it was a sale where I bought myself a teddy bear for $42.14 and it was 25% off or 25 hundredths off, right? Then I would be paying $10 and 5,350 10,000ths. What is that? So I'm going to put my dollar sign on here and remind myself that really we only have going to the hundredths. So from this point on, all this stuff here is money that we can't really deal with. But because this is a 5, I can round this up to $10.54 if we're talking a reminder about how rounding works. This 5, this bossy number 5 tells this 3 to go up, right? So $10.54 is what our final answer would be. All right, so I'm gonna have you pause this if you need to make sure you've recopied this math problem in, including the bumping of the arrows here to make sure that our decimal point goes to the right spot, because that's really, really important to make sure you have that in there, all right? So that's the end of our video. I hope it was helpful as a review. Even if you are a master of multiplication, I still want to see these notes copied into your journal, all right? Thanks a lot, and have yourself a fabulous afternoon.